Okay, I'll wait for you. Basic trig identities.
Yeah.
You're gonna have to pay attention and put your thinking caps on, right? It's new stuff to you, right? It's all trigonometry. So we take trig that we know, right? Sine, cosine, tangent. Trig, sine, cosine waves. And we take the algebra we know, right? And they go kaboom.
And then
And they collide. Okay, so we are doing a bunch of algebra with all the trig that we know. Okay. The ultimate goal here would be to solve trig equations. Okay. You've already done this a little bit. Like if I said the sine of x is 1/2. Calculate the value of x, right?
Yeah.
You can use the unit circle. What's the value of x in radians?
60.
Wrong.
30.
Wrong again.
45.
Wrong again.
No.
Because you aren't following directions. One of those numbers is correct for degrees, but not for radians.
Oh, in radians is what you want?
Yeah, so what degree would this be?
60 degrees.
No.
90.
Okay, we're guessing.
30 degrees.
This is where we put our thinking caps on and we actually think it through instead of guessing.
45.
Okay.
Oh, wait.
Okay, unit circle.
Yeah.
Sine is up and down, right? And 1/2 is the short.
15.
So this is 30 degrees, right?
Yep.
And radians, that would be times pi over 180.
Yes. 5 or 6.
Okay. That's a basic, very basic version of what we're going to do, right? Except that we're going to start solving equations like sine x plus cosine x equals 1. Where? Right? So this is where we're headed. More complicated trig equations. It's an algebra problem with trig in it. Right? Okay. So, yes.
I don't want to do a lot of them.
Okay, so the first thing you need to know is what is an identity? Let's go back. Okay. An identity is an equation that holds for all values of x. Okay. Here's an algebraic identity. That look familiar? That's an algebraic identity. We know it as the difference of two squares when we factored. Right, so x squared minus 49, right? How'd you factor that? Yeah, it's x minus 7 and x plus 7, right? Okay, this is the generalized identity for that. Okay, you put an x and a y in, it'll work for any x and y. That's an identity, right? We work with a lot of equations that are not identities. Okay. So part of this chapter is proving those are true or proving they're not true. Okay. So we're going to be proving that these are true or false. Okay? So this is a very logical thinking chapter. Okay. Okay, to show something is false, so can you think off the top of your head a formula that we use very, very commonly that may not work for all x values? Here's one that comes to mind. Whoops. Does that work for all values of x, y, and z? So if I can plug any three numbers in there, does it work every time?
No. Yeah.
Prove it.
No. That's.
Because you're right. The answer is no.
How do you do that?
Right, exactly. Okay. We're going to do something. Okay, so to show this is false, we use something called a counterexample. Okay. A counterexample is putting numbers in and showing it doesn't work. Okay. So take your pick. 1, 2.
Two I.
We're going to be realists today and not work in the complex numbers.
I mean, it's 3, it won't work.
Okay. Right?
Yeah.
So we get 9 and 5. Does that? Nope. You've just proven this is not an identity.
Oh, yeah.
Okay. So
So it's just saying you cannot plug. Oh, I get it.
therefore, Pythagorean theorem is not an identity. Identities always have to work.
No
Always.
matter what, three numbers are in there, and no matter what.
Any numbers.
So,
Okay. That is not an identity because there's some numbers that don't work. It's called a counterexample. So when you are asked, show this is not an identity with a counterexample, you have to put numbers in that show that it doesn't work. Okay.
if I were to put like,
So proving an identity is false is really easy. Okay, you're just searching for numbers that don't work. Okay, we'll spend a majority of our time proving that statement right there. So what are you gonna say?
so like, the counterexample is that same one to be 6 squared equals 2 squared equals 3 squared.
Yeah, that would work too.
Versus any three numbers.
Any three numbers that don't work show it's not an identity. Right? Okay. Let's look at a trig counterexample. Okay. Does
How do you prove it? It's true?
Everybody's doing the same thing.
Well, I know, but like,
yeah, well, that's
who's to say?
most of our chapter is devoted to that.
Like, who's
Okay.
to say there's like out of a million possible like numbers you put in, there's one you have to find that one.
Well, if it's true, then it'll always be true, is what you're saying.
Well, I could plug in some sort of like type.
Okay.
Pythagorean theorem, it's true, and then we're gonna plug in there.
Okay, or is this an identity? Here's another way to say it. Is this an identity? Okay.
Wait,
No. I don't know.
Okay, your answer, you said no. Why? Prove it.
Plug in 30.
Kellen.
I was just wondering, real quick, the Greek alphabet letters, are those just variables? Or do they?
Yeah, this is just, it'd be the same as saying sin x plus cosine x equals tan x. You know what letter that is?
Theta.
Theta, yeah.
So, just any degrees, you know?
Yep. I just pick one and plug it in.
20 and 30.
That's on the unit circle, makes it easier.
60 and 90.
Okay, and then do the math. So you can only pick one, there's only one variable.
Yep.
30.
Okay, so let's see if 30 degrees produces a counterexample, and that's a question mark.
Let's find out.
Okay, so unit circle brains, because you have a quiz tomorrow. Sign at 30.
1/2.
Okay, we've already done that. Thank you for answering correctly.
Root 3 over 2.
3 over 2.
Yeah.
Root 3 over 2 over 1/2. Oh, wait, no.
Flip it. You did cotangent.
Wait,
Tangent is
1/2
sine over cosine.
Oh, so 1/2 over root 3 over 2.
Yeah.
One.
All right, so
One over
1 plus root 3 over 2, right? Combine the fractions. Does that equal
1 over root
1 over root 3?
Well,
And that's root 3 over 3, right?
yeah. That falls.
So, are those equivalent?
No.
They're not. You might have to throw that in the calculator. And you'd say, therefore, this is not an identity. Okay. Do you guys know the symbolic therefore? So up here I wrote therefore.
Yeah.
If you write this,
Like 3 little
the
dots.
predator's gonna get you. Right. No, that in math talk is therefore. So I could say therefore sine theta plus cosine theta equals tan theta does not equal. Okay. Part of being a good note taker is using shorthand. So instead of writing 9 letters, you can write 3 dots, and it's the same thing, right? Because it allows you to pay more attention and process better instead of writing letters all the time. Okay. Yeah, it makes life a little easier. You just have to learn all that stuff. Okay, so that's showing an equation is not an identity with counterexamples. Think you can handle that?
Sure.
How do we prove that they're true?
Sure. I told you that's like the next 2 weeks of our lives.
Well,
Okay, there we go. Okay, let's look at the first few identities we're going to learn. These are the reciprocal identities. We want to make sure that.
So is it like a
And you already have seen these.
Let's start at 30. Proved it is true. Does that have to pass like a bunch of tiers, like that one, like that one thing we did where like discontinuity?
Okay, so
Is it like that? Where it
since
has to
the youngest one in the room is curious, if I were to prove,
Well, I'm just asking, like.
I know, I get it, it's fine. If I were to try to prove this is an identity,
Does that have to pass?
I have to algebraically simplify this with using other identities
Okay.
so that we get tangent equals tangent.
Oh.
So I would manipulate these using other identities, which you're going to learn all the basic ones the next few days to get 2 sides equal to each other. Okay. But like I said, we have to learn the identities first. Okay, the reciprocal identities. Here's where these are based. You know that sine of some angle is opposite over hypotenuse, right? Right? Right triangle trig? So katoa? Okay, do you know what cosecant is?
That one.
H over L?
Yeah. Okay. See how those are reciprocal?
Yeah.
Yeah, that's where all these come from. Right.
Oh.
So I can write sine as an identity with cosecant in it. It's 1 over cosecant.
That's true.
That's true. It's an identity. I'm telling you right now it's an identity. And you can actually prove it using that statement on the right side of the board. If you want. So, do you want me to show you how I would use that?
Yes, sir.
It's very, very straightforward. Okay, we know that, so here's your sine theta equals 1 so cosecant is OH over O, right?
Yeah.
Okay, so I've just changed cosecant to hypotenuse over opposite using an identity. Now we fraction math it, right? So you get sine theta equals 1 times copy dot flip. Is that true?
Wow.
Yeah, you've just proven this identity is true. This is a very basic example of what you're going to be doing. Okay. So you take information you know is true and use it. Okay. So you're not going to have to do that today, right? But that's just since you asked. Okay, what are the others? What is cosine the reciprocal of? Secant.
Why did they make it that way?
And tangent?
Okay.
Cotangent. And what are the other three? Cosecant equals
Yes, the other one.
1 over
Yes.
sine. Yeah, secant is 1 over cosine, and cotangent 1 over tangent. Okay, so 6 identities you've subconsciously worked with before. We haven't formally put them up, but there you go. Okay. Good with that?
Yeah.
We've already used, I'll show you how to use those in a second, in a minute, maybe 2 minutes. We've already used this identity today. Tangent is not only 1 over cotangent, it is also sine over cosine.
Cotangent is cosine over sine.
Right. Oop, that should have a theta with it.
Are all their degrees the same?
Yeah, these all will match. Theta, 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 all the same, right? We use that, right? There. So you already knew these things, you just hadn't used them in this format, right? This is the sine value, a half over the cosine, root 3 over 2, right? That's tangent, sine over cosine. Okay? So you've already used all this information before, it's just putting it in identity format. All right, so how do we use these? Here we go. Okay. If secant is 3 over 2. Calculate cosine of theta. You've done this problem before. Secant's 3 over 2. What is cosine? Say it. Yeah, that's it. They're reciprocals, right? Nope. Don't be dumb. Yeah, they're reciprocals.
Wow.
Okay. So you've already done that problem before. And that's as far as we're going to go today. Right? Yeah, that's, I mean, the stuff we've kind of done before, but it is still a lot of information that's in a different format. Kellen.
Is this only applicable to trigonometric functions like cosine and stuff like that? Or is there other functions out there that are also this?
I'm gonna have to think about that one. The answer is probably yes,
Yeah.
but I just can't think of them right now. Okay, so yes, there are reciprocal functions that are reciprocals of each other. Yeah, I'd have to think that one through before I threw it up there. I don't want to confuse you guys. It's a good question. Very good question. Okay. This is today and tomorrow. What I'm going to put on the board. So this is not going to be due till Tuesday. Okay. Let me make sure. Okay, yeah, so
No, I'm good.
Is that 69? Why is it 69 and then 68?
let's add number 1 on there. Okay, so it's only 4 new problems and then a bunch of review, right?
So is that 64? Or 69 on top right?
65.
Thank you.
Yeah. Okay. Okay, you've got about 15 minutes. Let's use our time wisely.